What's going on, guys? It is a mess in here. I'm actually in the middle of fixing a game. Here, I'll show you. I'm testing and repairing a Cosmic Gorilla board for a guy, so now everything's kind of in a disarray over here. And at the same time, a buddy of mine shipped me 2 Space Wars soundboards. He says if I fix one, I get to keep the other, so I got this all pulled out. I was working on that. But the thing I kind of want to do, and this won't take me long, but I kind of want to overclock something. I kind of had fun overclocking the Asteroids board I did. And I'm kind of excited about the larger processor coming in for my Vectrex. So, since the processor has not come in the mail yet, I do have a special processor that I can upgrade a gravitar with. So, the only reason I'm picking gravitar is because it is right there at the end of the row. It's so easy to get to. So, let's overclock a gravitar. Alright, so I have the board here. I have it on my kitchen sink here. And there's going to be certain things that I'm worried about locking up. Now, I haven't looked into this. I'll find out in a second here, but it looks like 12.096 is the base clock frequency. And so that's going to be divided down to run different parts of the board. Okay? And one of those will be divided down into is CPU frequency. So I'm going to change just this crystal, and we're going to see where it goes. Now, there's going to be certain things that are going to hold us up on this, because I'm not going to sit here and design an entire circuit to slow down the clock for the EPROMs and whatever. You know, I'm just going to do one giant chip right there, and that's going to cover everything. So first things first is I'm going to try to see. I'm pretty sure, but I'm going to find out if a 65 CO2 chip is compatible with this. Because that's a standard 6502 processor. So I'm going to plug it in and test it, and if there is any issues, I'm going to have to do some rewiring for it to work. Simple stuff though. But, okay, so the things that may hold up, I suspect will hold up first is the ROM speed. Now, if you run these faster than they're designed to run, they won't work. Or it'll give you data at the wrong times. And the second thing I suspect is, once the clock is running faster than normal, we may have a problem with the AVG chip, which is the Atari Vector Generator. So I just happen to have almost every AVG chip, replacement chip ever made. So I'm going to try each one of these. If I have any graphical errors, we're going to see which AVG chip can run at the higher clock frequencies. And I'm going to try to clock it at a slower speed also, and we'll see how that works. Well, I plugged in my 65 CO2 processor, and if you see here, we have a working game. So that's really cool. Now the specific model 65 CO2 processor I put in is capable of handling 14 megahertz. So yeah, I believe the original is 2 megahertz, but let's find out in a second here. And let's see how high we can get this sucker to go. Okay, if you can see in the center of the picture here, I tore apart a machine pin socket, and I put 2 machine pins here. That way I can just plug in the crystals of the oscillators one at a time without soldering and desoldering and soldering and desoldering. That way I can not damage the board. Okay, at first I plugged in a 20 megahertz crystal, and I expected it not to work, you know what I mean, but just in case, and it did not work. I had spot killer, so then I tried to disable the watchdog circuit, and it still did not work. So I moved along, and I was thinking that maybe 16 megahertz might be the top, but believe it or not, I have an 18.95 megahertz crystal actually running. No spot killer. 18.95 megahertz, but look, we have some problems. Sucker's running though, and man, it's cycling through the game like you wouldn't believe. Boom, 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 boom. Okay, so I'm going to swap out the AVG chip and see if that fixes it up any. Okay, so the first AVG chip I'm going to try, AVG chip replacement, is Clay Calgill's AVG chip made back in 1999, and the reason I think this chip's going to win. But anyways, the reason I think this chip is going to be best for overclocking is because it's all TTL. This TTL, it's mostly all TTL, and you can run TTL pretty fast. Okay, now chips like this one have like a little microprocessor inside and things like that, and maybe things might be coming in faster than they can read it, or I don't really know. And you know, these are reproductions of I don't have any. I actually gave away all of my original AVG chips. So yes, put them on boards and sold them and things like that. Now the original chip might be better, but honestly, I don't have one. But okay, these are new things. The AVG chip was pretty failure prone. Okay, they died randomly, and then sometimes they lived forever. You know, so it's kind of weird. But no one really knows what's inside an AVG chip. What a bunch of smart people have done is monitored the inputs and monitored the outputs to reverse engineer and make something that will do the same thing as an AVG chip. But that's only made because they monitored certain specific conditions. If the conditions were to change, it might be different. So this is a very, very close representation of an AVG chip. So let's try this thing and see what happens. Well, now we're running Clay Calgill's AVG chip, and we have the exact same issue. At least it seems to look the same to me. You guys might notice something different when you watch the video, but yeah. Oh yeah, you know what? I think it's hard to tell. It looks like the same issue to me. So I'm leaning towards this is possibly how it's reading the graphic ROMs or whatever. I don't really know. But let me bring it down a few specs and let's see where we can get a stable game out of this thing. Okay, I wish I had a 17 megahertz crystal, but I do not. So right now we're running at 16 megahertz. Okay, so as a point of reference, I want you guys to try to listen to the sound when I first start the game. Can you hear it? Well, 8.4 is the lowest I can get it. Now I did have an 8.19 crystal, and it was glitchy. I mean, it was freaking out. Just a steady game, I got it running at 8.4 megahertz. The interesting thing is, Clay Calgill's AVG chip is the only one that can run this that slow. I tried every other type of AVG chip I have, and they all crap out at frequencies this low. And Clay Calgill's is actually still chugging along. It's interesting because when it's clocked this slow, it actually increases the picture size. Isn't that interesting? Okay, so let's listen to it. That sounds slower. It's interesting how that picture is like so much larger. I think it gives it more dwell time for the monitor to honestly, I don't know. Not quite sure. But yeah, well, yeah, let me coin it up. It sounds kind of cool when you coin it up. I'll get my hand in there. Okay, if you're familiar with gravitar, you might recognize the sound when you first coin it up. Listen to it at this clock speed. It actually sounds way more badass, don't it? Oh, by the way, let me this one I'm gonna do. I'm gonna start this game, and then I'm gonna play a clip of the slowest clock speed I was able to do, and then I'm gonna play a clip of the fastest clock speed I was able to do. Now, remember, the sound I'm trying to use as a point of reference is that Pac-Man rear sound, okay? Can you hear it? Well, I got it all back together. I put the original 6502 processor back inside, and then just for giggles I ran those same frequency clock speeds with the original processor, and it still ran just fine. So the hang-up is not the processor. The hang-up, it must be the speed that it reads the ROMs at. So, well, I have the gravitar schematics on the TV here, and this crystal right here, the 12.096, was the crystal that I was messing with, okay? Now that basically goes through a circuit to kind of like reverberate, and then it goes into this counter, okay? And it basically divides the clock frequency by 8. So the original clock frequency is 1.5 megahertz. That's what it was originally clocked at. And when we clocked it at 16 megahertz, we bumped the CPU clock up to 2 megahertz. And when I underclocked it at 8.4 megahertz, we had the processor running at basically 1 megahertz. Now it's interesting. I mean, these are very similar results to what I seen when I overclocked and underclocked the Asteroids board. I really do think my biggest limitation is how fast it can read its own ROMs. Now, if that could be, which it can be, that could easily be done. Now, if you were to modify it to, or actually put faster ROMs in, we could actually see how fast it would go. But I'm not that interested. All right, guys. Hey, if you like my videos, please subscribe and have a good one.